Hi, my name is Kiran, and I'll be explaining the part wherein like we'll be coming up with our own algorithm to implement the CGM prediction. Uh, so as you can see here, like we're still working on this part. For now I'll be explaining the pre-processing part, like what we have. Initially developed to pre-process the existing data, which we can later leverage for our final prediction of the model. Um, initially, what I've done is I've imported the final data.csv file. The data is of this format. If you can, what is being shown in the screen. So we have 4 columns. The first column is date of CGM, and the value. Second column is value of CGM, and the first column actually corresponds to the date on which the value was actually noted, and the third column is the bolus date, and the value is the bolus value. So I'm just fetching it, since the date here is in a string format. I'll have to convert it to a time format. So I'm just reading this CSV file. I'm just reversing the rows and creating a new data frame here. What I'll be doing is I'll be taking the CGM date, and I'll be converting it to a year month date and hour minutes seconds format. So using that, I'll have some extra parameters that I can use for to later classify my data into various subsections, and this is what I've done. So everything else, like I'll just have extra columns in my new data frame in terms of date list and hour list. So whatever date time object is fetching here, so I'm just taking the first and second parameters of it, just to get the date and hour from it. So, and also for the target value, if the value bolus is greater than 1, then I'm labeling it as meal, and if it is not, I'm labeling it as a non-meal. So if you can see here, there are most of the values are 0, and which means it's a no meal value. And if the value is above 1, which in cases like these, so I'll be labeling them as meal. So all this list that I've created in the previous step, I'll be making them as columns to my new data frame. So this is one of the helper classes that I've written, wherein I'll be grouping all the values based on the date and hour. So on a given date and on a particular hour, all the values that is being noted, I'll be storing in this list, which is called grouped. So what I'm doing is I'm creating a updated final data CSV here. So if I'm just opening this file and showing, so this is the final CSV that we have got, which we'll be using for our further prediction. So it's in this format. The first one is actually the time which we have got, and the BG is actually the value CGM what we had in the previous data frame, and value bolus and all the same. So these two columns, as you can see, like these are the two new columns that we have created. So this is the CSV that we'll be using in our future prediction. So if you want to have a look at the data, so this is how the data is going to look. So it's basically every row is a list of tuples, wherein the first value of the tuple is the CGM value, and the second one is actually the label that has been assigned to it. And if you can see here, there are 4091 rows, and every row is looking something similar to this. And this is the entire data. So I've just created a a bar plot, a histogram plot of all the different sizes of data that we have. So if you can see, 33 is the longest sequence that we've got, and uh, the number 12, like there are more rows with 12 values in them. So this is more about the pre-processing part. For the model part, we are planning to implement long short term memory, which is an LSTM model, which we are currently working on. So I've not actually put the code here, but just to give a brief introduction about LSTM. So LSTM is an artificial recurrent neural network architecture used in the field of deep learning. Like, I mean, unlike standard feed-forward neural networks, LSTM has feedback connections. It can process not only single data points, but also entire subsequences of data. Uh, the call is a common LSTM unit is composed of a cell, an input gate, an output gate, and a forget gate. The cell remembers values over arbitrary time intervals, and the three gates regulates the flow of information into and out of the cell. So this is a brief introduction about LSTM, which we're going to implement as which we'll be using for implementing our algorithm, and yeah, which we'll be submitting for the final submission. So thank you.